Welcome to the Robotics Challenge. This is your first program, and we're going to try to teach you a little bit about basic robot technology and how to adjust programs so that the robot has different levels of power and goes for different amounts of time. To do this, you're going to have to open a program. You're going to want to go to File, Open and Compile, and you're going to want to open programs within the Robotics Challenge Programs folder, and the program we're using is Moving and Power. So let's explain this particular program. At the beginning of most programs, you will always see Task Main. This essentially never changes. It just means that what follows Task Main is going to be the main program. So it doesn't really do anything, and it never changes, but it always has to be there. Then the entire program will be written within the first bracket and the last bracket. As programs become more complicated, you will need to add more and more of these brackets. The brackets encapsulate different pieces of the program, but more on that later. So let's explain this program. Your robot has 3 motor ports, A, B, and C. It's important that when you plug in your motors, they go into the A, B, or C port and not the 1, 2, 3, or 4 port. The ports with numbers are reserved for sensors, which again we will get to later. So let's look at this particular line, line 6. This line says that a motor named motor B, which means that that motor must be plugged into port B, should be turned on at the 100 power level, which is full power. Let's look at the next line. This says another motor, the motor that's plugged into port C, should also be at 100 full power. These robots work like tanks, so that if you have a driving robot and both motors are going at the same speed and in the same direction, it's going to go straight ahead. In this case, full power, straight ahead. Next line, wait 1 MSEC. This is a little bit counterintuitive. It doesn't mean that it will wait 500 milliseconds before it turns on. It means that it will do whatever the commands were before that for that amount of time. So in this case, the motors were on, both motors, B and C, were on at 100 full power, and we are going to do that for a number of milliseconds, 1 millisecond times 500, or 500 milliseconds, or in other words, half a second. If we wanted to go forward for a full second, we'd go forward for 1,000 milliseconds. If we wanted to go forward for 2 seconds, 2,000. So very simple. If you want to go longer, increase that number. Wait 1 MSEC usually doesn't change. What if we didn't want to go so fast? $50 is approximately half speed. Slower would be 40. Even slower would be 30. What if we want to go backwards? -50. That would go backwards at half speed. What if we want to stop one of the motors? What if we want to stop both motors? There you have it. That's going to be just about all the different things you can do with motor power. But let's suppose we wanted to do go forward and then turn. Well, let's go forward at 100%. Both motors forward at 100% for 2 seconds. What if we wanted to turn after that? Probably the easiest way to modify your programs today will be to copy parts of the code. I use Control C, and then paste it. Control V. Make sure that it's in front of that last bracket. Anything after that bracket will not get read by the program. So the programs work in a linear fashion. They'll do what comes first, they'll complete it, and then they'll do what comes next. They'll complete it, and they'll do what comes after that. In this case, there's nothing after that. So this is going forward because both motors are going the same direction. What if we said, let's go forward, and then let's go backward? This program says go forward for 2 seconds, then go backward for 2 seconds. Since there's nothing left, it ends. So your first hands-on challenge for today is to run your program forward for 5 seconds and then reverse for 5 seconds and then get that checked off.